Okay, here's a problem in finding the weighted average cost of capital. Midwest Electric Company uses only debt and common equity. It can borrow unlimited amounts at an interest rate of R sub D of 10% as long as it finances its target capital structure, which is 45% debt and 55% equity. Last dividend, so that's D sub 0, is $2. Its expected constant growth rate is 4%, so it's a constant growth model. It has common stock selling for $20 per share. They have a tax rate of 40%, and they've got two projects. Project A with a rate of return of 13%. Project B has a return of 10%. So what we want you to do is to find the WACC and then determine whether or not they should adopt either one or both projects or none at all. So to try to take a look at this, what we want to try to do here is to break down the nature of a weighted average cost of capital problem. And what we have is this, is that the weighted average cost of capital, in the case of somebody who has only debt and equity, it's the weight on debt, the percentage, times the rate on debt times 1 minus the tax rate. That's what its component cost would be. And with respect to common stock here, WS, there's no tax advantage, so the after tax and pre-tax are the same representation here of R sub S, the cost of retained earnings. We're assuming in this problem that you have enough retained earnings to meet whatever this demand would be. Now, all we're going to do at this point in time is begin to substitute in this information that we have. So if you go back here and take a look at these within the problem, we find that we've got a weight on debt of 45%, so 0.45, which we're going to multiply by the cost of debt or yield to maturity of 10%, 0.10, and we'll multiply that by 1 minus this 40% tax rate for that whole component cost. Over on the other side here, our remaining weight, or 55%, 0.55, is in the form of equity. And the cost of that equity is what we're going to have to determine here by using this constant growth model. So we want to be able to plug in what that information would be. So if you look at each of these, again, just substituting everything in, we need to know what R sub S is. So where we've got R sub S from our constant growth model as the dividend at the end of the period relative to the price at the beginning of the period plus the growth rate. Well, you've got a 4% growth rate, and the dividend at the end of the period is the $2 that just happened times 1 plus this growth rate. We're going to look at that relative to the $20 price. So you have $2.08 divided by $20. And we'll add to that the 4% overall growth rate that we're going to be using in here. So when we go ahead and look that up here and we're looking for our R sub S, again, it was just our $2 times 1 plus this growth rate of 4%. That's the next dividend divided by the current price. And to this, we're going to add the 4% growth rate. So you get 14.4% is going to go into our problem. And so if you were to plug that in up above, we can go ahead then and calculate that WACC. So again, taking a look at this problem, we want to put in this. The weight on debt times the cost of debt times 1 minus the tax rate plus the weight on equity times the cost of equity that we had just found, and that'll give us our weighted average cost of capital. So we go through there. There's our weight on debt of 45% multiplied by the cost of debt of 10% times, again, 1 minus the tax rate. And so there's our 40% tax rate. To that, we want to add our weight on equity of 55% multiplied by the cost of equity that we just discovered here. And that gives us a 10.62% for our weighted average cost of capital. If you prefer that in percentage terms, we can certainly change it to represent that. So there's our 10.62%. Now, on the second part of the problem where it says, should we adopt either project, the whole part in referencing this as a cost or a weighted average cost is to say, this is what it's going to cost from all of our sources to acquire our funds. So we must be able to get at least 10.62% from a project to justify it. Project A has a return of 13%, so certainly we can justify Project A. But Project B only returns 10%, and it's going to cost us 10.62% for a project, so we would say only adopt Project A, since the cost is less than the return. And there we have it.